Hello everyone, this is Dr. Fan. Newton's laws are the foundations for classical mechanics, and in the previous video we discussed about Newton's first law, and today let's discuss the Newton's second law. So the Newton's second law basically says the acceleration of a system is directly proportional to and in the same direction as the net external force acting on the system and inversely proportional to its mass. So if we use a formula to express that, we got acceleration equals to the net external force divided by the mass, or the very classical one, F equals ma. So this shows the mathematical relationship between them, but also remember the acceleration and the force, they have the same direction. Alright, let's see if we really understand Newton's second law by doing some practice problem. So if we look at these different situations, if we use a force of F push a mass of m, if the acceleration is a, what if we double the force? Based on Newton's second law, if you double the force and keep the mass as the constant, so your acceleration will double. And let's look at another different situation. You use a force F, push a mass of m, and the acceleration is a. You keep the force as a constant, but if you double the mass, then the acceleration becomes half of your initial acceleration. This is very straightforward because it basically says the acceleration is proportional to net external force and the acceleration is inversely proportional to mass. Alright, now let's look at a harder but interesting question. So this question says, a person stands on a scale which is placed on a moving elevator. While the elevator is moving, his weight is larger than his weight measured on the same scale on the ground. What are the possible motions of the elevator? So this is a very interesting and a classical example. If we consider this person as our system, and if we consider going up as the positive direction. So if we want to apply Newton's second law, then we need to know the net external force. So if we draw the free body diagram, the gravity is going down, and the supporting force from the scale is supporting this person. Fn going up. So the net external force is Fn minus Fg. And based on Newton's second law, the net external force equals to mass times acceleration. So let me use a different color. So this question says his weight is larger than his weight measured on the same scale on the ground. In other words, the supporting force from the scale while on this moving elevator is larger than his weight. In other words, in this case, Fn is larger than Fg. If Fn is larger than Fg, that means this equation is larger than 0. That means my acceleration is larger than 0. And remember, going up is the positive direction, so that means my acceleration is going up. So what are the possible motions of the elevator? One possible motion is the elevator is moving up. Elevator is moving up. That means the velocity is going up, but also speeding up. So the acceleration is becoming faster and faster. So this is one possible situation. And the second situation is the elevator may be moving down. The elevator may be moving down. So the velocity is going down, but it is slowing down. So in this case, the acceleration is also going up. So under both scenarios, your acceleration is going up. And under this situation, we know the normal force from the scale, which is the apparent weight, is going to be larger than the weight on the ground. Alright, what if the elevator is moving with constant velocity? If the elevator is moving with constant velocity, that means the acceleration is 0. That means the normal force from the scale equals to the weight. That means his weight should not change compared to his weight on the ground. There is another very interesting scenario in this case, that is, what if the normal force becomes 0? If the normal force becomes 0, that means this person becomes weightless. And if the normal force becomes 0, that means the net external force equals to 0 minus mg, which equals to mass times acceleration. If you look at this equation, what does that mean? That means your acceleration equals to minus g. So if the number on the scale becomes 0, that means the person is moving down with gravitational acceleration. So this is a free fall situation. Maybe you have experienced this in the amusement park a lot of the time, and it's a lot of fun. Alright, now let's look at another practice problem. So the question says, does the motion of the block going up or down the ramp changes the acceleration? So if we look at this question, if we want to know the acceleration, then we just need to utilize Newton's second law. The Newton's second law says the net external force equals to mass times acceleration. So if the net external force changes, then the acceleration changes. But if the net external force does not change, then the acceleration does not change. So if we look at this question, we can draw the free body diagram. So this is our system, which is our block. We consider this is our positive x direction. This is our positive y direction. If I use a different color, the object is under Fg here, and then the normal force here. So whether the block is going up or down, if we consider there is no friction, the force is not changing. So the net force, net external force, would not change. So the acceleration would not change. If you are interested to find out the acceleration, we can do the force decomposition. So we know if the incline angle here is theta, then this angle here is theta. So if we look at the net external force along x direction, so that would be the horizontal component of gravity. So the net external force along x direction is Fg times sine theta, which equals to max. Along the y direction, sigma Fy equals to the normal force going to the positive y direction minus mg cosine theta, or you can see Fg cosine theta, which equals to the acceleration along the y direction. We know the block is going to move up and down. It's not going to move along y direction. So along y direction, the net external force is 0. And at the x direction, if we look at this equation here, we basically know mg sine theta, which is my net external force along x direction, equals to mass times acceleration. So my acceleration would not change, which is always g sine theta. So the acceleration would not change whether the block is going up or going down. So the key thing here is I want to show the acceleration is only determined by the net external force. And of course, this is the situation if there is no friction. If there is friction, then the friction changes direction, the situation will be different. But regardless of which situation, the acceleration is determined by the net external force. That's exactly what the Newton's second law says. Alright, let's summarize what we have discussed. So remember, Newton's first law basically says, if the net external force is 0, there is no change of motion. That's what Newton's first law says. Newton's second law says, what if there is a net external force? Newton says, don't worry, you're just going to have a change of motion. And how fast or how big is your change of motion? That is your acceleration. So your acceleration times mass equals to your net external force. Or you can see your acceleration is determined by the net external force divided by mass. And remember, the net external force and acceleration has the same direction. Alright, that's what I want to discuss today. Hopefully it helped you guys to better understand Newton's second law. Thank you, I will see you next time.